Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. The session will run approximately 1 hour with questions throughout, and I'll now turn it over to Sam for introductions.
Hello, everybody. I am Sam Wronski. I am a regional cloud advocate here at Microsoft. My job is to help empower all of you to create and build really awesome things with Microsoft technology. So what we're doing today is taking a look at SignalR. So this is going to be a project we're going to work on over the next 3 weeks, and we're going to kind of be taking this in steps. First, looking at what SignalR is and how you can use it, and then looking at how we can integrate that into a web app. And then we're going to be integrating that and actually building something in the third part of this so that we can actually hopefully use it. And so it's something that you can actually find and use when you visit some of our reactor spaces wherever you are. So that's sort of what we're going to be building. I have actually already built this sample, and then we're going to kind of walk through how you can actually recreate everything that I'm going to show you here. So if you want to follow along, all you'll need is .NET, and we'll show you how to do everything else on the way. And this is definitely something that you can create. We're going to be creating this. So this is a 2-project solution that has a server side and a client side. SignalR is a client-server communication framework that lets you send events to a server, which then can broadcast those back out to clients. This is different than a peer-to-peer network, where you might have a number of people located all over the place, and they would directly send messages to one another. Instead, you'll send it up to a server that is aware of everybody that's connected, and that server will be responsible for distributing those messages. So that's how this works. This is the server component. This is all the code. There's not much here, and that's sort of the cool thing with all of this. So this is just based off of a ASP.NET Web API project that we've created. It has Swagger, though the Swagger doesn't do much. And then we're just adding in our SignalR component to this project. This all works through a series of hubs, which are sort of your message handlers. They work very similar to web request endpoints that you might have. So typically you'd have a REST endpoint that you would send a request to, and then the server would process that and send a response back. In SignalR, you don't have that. Instead, you have a hub, which has a series of, I believe, I need to double check the term, but they will have specific names, and then those will be the events that you broadcast back out. So you will send a message up to those events, and those events will handle something on the server, and the server will be aware of all of the clients connected to it. So that's using this hub here, which is this, I'm calling it the Project Pixel Party, because we're going to be able to draw and send images back and forth between different things once this is complete. We're not going to get there in this session. This is entirely focusing on building like CLI experiences from this, just so you can kind of get started and start understanding how these tools work. And then we'll add complexity over the next 2 weeks. So this is what a hub looks like. There's not much here either. And now you've seen the entire code of my server. So this hub, the important thing is that it's extending a hub, and then it has this name. This name is the name of the event that we're going to send. So we've set up a hub in our configuration, and now we can call Pixel Update on this server. And we can send those same messages back to our clients. And so that's what this is doing. Is just finding all the clients and sending them an async message that is a duplicate of the message the server received. So all the server is doing is rebroadcasting the exact same message from all of our from all of our clients back to the server. So there we go. And that's that. The other part is the client side, which is just connecting to that, reading that, and then able to broadcast things. Hello. I don't know how to say that name. Yeah, sorry, I don't know how to pronounce it. Is there a good way to do that? But hi, welcome to the stream. Hopefully, hopefully you enjoy it. So this is what we have here. I'm going to show you how to implement this, and we're going to kind of walk through it as we implement it. So I'm not going to talk about it now, but I am going to show you what the end result is going to be. And then we might add a few things on depending on time. So if we start our server, this is going to launch that server component that I just said. Hello, Sam from Seattle. Hi, Jay. I'm actually located in San Francisco. So I'm part of our regional advocacy team. We have a series of people who are kind of located all over the world, and we kind of run local events in different places and help work with those communities. So I focus a lot around the Bay Area. Jim Bennett focuses a lot more around the Redmond and Seattle area, if that's sort of what you're looking for. But yeah, hi, welcome. So we have started our thing. Because we added Swagger, we're going to get this thing. Oh, I meant to type I'm in Seattle. Okay, that makes a lot more sense. Hi, Jay. So we have this Swagger spec. This in our case does not make that much sense because there's nothing here. If you're unfamiliar, Swaggers and Open API are ways for you to document what your web APIs are doing. It will show you the REST requests that you can make against that service, and it will show you the parameters and response types that you might expect from those. In this case, we don't have any. So this is empty. We're just generating this. We could remove it, but it is nice here just because then we actually know that it works. Because this popped up, we know that our server has started. Maybe not the best way to do it, but that's a way to do it. So we do that, and then we can actually run some clients. So we have our thing running. So what we can do now is go into our CLI project that we had there and do .NET run. And we're just going to run these from the console. And I'm going to actually run 2 copies of this. How does this scale? If you have 100 endpoints, it is fast. But if you have 100,000 endpoints, how fast is it? I don't know, Mark. That's not a case that I have gotten to myself. So I can't actually answer that. That would actually be something that I could look into for you, though. So with what we're building here, my intention is to deploy these into our reactor spaces for various reasons. So when I was researching this and trying to figure all of this stuff out, scale was less of a concern for the design that I was going for. So I'm not sure where the cap is and how high you can vertically scale this. I believe there's a way to horizontally scale SignalR, but I haven't played too much with that yet. But if that's something you're interested in, send me a message and I can follow up. But yeah, otherwise we might even be able to find a way to do that because that sounds fun. So we have our one client running. The way these clients work is they get started, they connect to our server. That's what the connection started message is. And then they're going to send an update. These clients don't print anything when they send that. They only print it when they receive the message. So what happened when this first instance ran is we actually sent a message up to our server and got it back and then printed out the results. And so if I actually run this other version and it's the same project, same location, we're just rerunning the same thing. We got our message there, but we also got it over here as well. And then the way this works is every time I hit enter, it generates a random new series of parameters and sends them back over. And now both of our clients are seeing the same message. So they're both getting at position 2014, they get white because we're working with colored pixels. So RGB is just set to white for this. So eventually we'll just get a big white thing. But that's what this is doing, is it's just sending back and forth pixels. And so you can do that from either side. Either client can send messages back to the other, and the server will make sure both of them receive it. And so that's what we're building today. That's our end goal. So let's implement this. So we're going to start from scratch and build this entire thing just from nothing. And I'll show you how to do all of that, hopefully. We'll see how this goes because we might run out of time, but otherwise it should be fun. So I'm going to use this project as notes just so that I don't get lost and spend a lot of time trying to search up specific things. But I'm going to move that over there and we're going to jump back to this one. So this is an empty Visual Studio solution. There's nothing here. So what we're going to do is start adding stuff to it. So we need 2 projects here. That solution was actually using 3. Whether we use one or the other doesn't really matter. 3 seemed like it made sense because then I had my data models in a shared library that could be used by both the client and the server. So the data I was sending back and forth didn't need to be duplicated, and you didn't need to recreate those data models on both sides and make sure they were in sync. So we might follow that pattern here. So first thing let's do is create this class library. So I'm going to use the recent templates because I have them there, but you can do class library. This will also work from the .NET CLI if you're doing a .NET new project and creating it that way. You can also do that. So let's create a class library, and we'll just call this our pixel party .example.shared. Changing the names because I always do that in demos. And then .NET 6 should be fine for this. And we're just going to create this. I am going to put a semicolon there. So we're going to use file scoped namespaces. Cool thing with Visual Studio 2022, it removed the quotes automatically for me. So everything in this file is now in the same namespace. And then I'm just going to use a record here. Records are something I'm still learning, but they're a way to do data types that have a little bit more to them than something like a struct or class might. They'll come with equality, for example, built in, and they can be declared like this. So you do a public record, and we're just going to say our pixel data model, and then we can just start adding things. Let's say the first things we expect are X and Y. So what coordinates on the screen they should be. And then pixels are RGB. So red, green, and blue. Let's just add those as well. And there's our data. That's it. So this project is done. The only other thing I probably should do is rename class 1 to our pixel data model. And there we go. So that's all done. And we can build the next thing. So this will be what we're going to be sending between our client and our server. So we have something to communicate back and forth with. The next thing I want to do, just making sure I stopped it because otherwise we get weird issues. Next thing I want to do is create our server. I start with servers typically because I think they're a little bit easier to actually interact with. So if we do a new project here and go, let's do a web API. So ASP.NET Core Web API, and we're going to do a pixel party example server. Can you give out your email address? If you want to get in contact with me, the best way is probably through Twitter. My email or my username is actually on the screen right now. It's at RuneWake2. And so you can just send me a DM there, and then I can follow up. Otherwise, I don't really want to broadcast my email just generally without knowing who's getting it. But yeah, that's the best way. And then from there we can follow up and I'll figure out the best way to make that happen. So what else do we need? So OpenAPI support is going to add Swagger, that Swagger website that we saw. You should be able to leave all of these checked for now. We're not going to be using HTTPS directly, but this will work for this example. And this project actually gives us a little bit more than we need out of the box. So we get a sample weather forecasting app here. So we can actually just run this, I suppose. Let's set it as our default project because I always forgot to do that. And run this, and we should see something. I'm not entirely sure what. It's been a while. Oh, interesting. I don't know what that was. Okay, cool. Something happened. I don't know exactly what, and it's a little bit outside of what I want to be testing, so we're not going to fix that. Because what we're going to do instead is just delete all of this. We're just going to get rid of our controllers. We don't need any controllers here. Those are what we're creating those endpoints there. So we can just remove those. And this weather forecast is our data model that our server was returning. We don't need that either. We created a data model already. So what I'm going to do is just click and drag this up to our dependencies. That's going to add a project dependency to this. So we now have this as a project dependency. So everything should be synced. And then we should be good. So now we have our program and we just need to create something. So let me double check because I forgot the exact dependency here. All right. So we need to add the SignalR package. And so what that looks like is this. So if we go over to our browse here, again, you can add these through the CLI if you prefer. I'm trying to do this through Visual Studio just because I'm relearning Visual Studio. So there you go. So let's do SignalR, and we want ASP.NET SignalR right here. And so we can add this project to our server. And that's going to give us all of the dependencies we need for SignalR. That will allow us to actually set up everything and get it all working. And then it just integrates directly into ASP.NET, just like you would expect other things too. It's relatively small. I kind of showed that or hinted at that, I think, when I was initially building this. The server side doesn't need much code because all the server is doing is setting up this endpoint, which is sort of encapsulated inside of SignalR itself, and then adding on the hub logic, which in our case is just rebroadcasting all the messages back out. Now, there might be other things that you want to do other than just send messages directly to all the clients. You might want to filter that down and say, only send these messages to moderators or people with this specific status, or also save this out to a database or do something else. All of that can be added into the hub's logic. But basically a hub, from what I'm understanding, is a similar thing to a controller. They operate in very similar fashions. You will just choose one or the other. And a controller will work with REST, and a hub will work with these events that are coming in. So that's the difference. So here's our server, and we have our new SignalR dependency added on. And so now we can just start adding SignalR stuff to this. So there's two things that we need to do. First, we need a hub that is actually going to handle all of this. So I'm going to go and click Add New Item. And we're going to add a new class. There we go. So let's call this our Pixel Party Hub. I've been working with the name Pixel Party because it sounds fun. I needed a name, so that's what we're going with. Hopefully it's fun. And so we're just going to do that. Get some there, and there we go. And we can also, I think, move that into a file scope namespace as well. Again, those were added in, I believe, .NET 6. And it just scopes your entire file to a single namespace, so you don't need those curly brackets. So you'll see everything moves over to the left because we don't need that indentation anymore. So it ideally makes your code a little bit smaller. So now that we have this, we need to implement something. So the way this works is we create public methods, and those are the methods that are exposed out to our clients. So public methods here are things that our clients can actually send messages to, and will be exposed to them. And they'll be exposed by the name of whatever that is. So what we can do is just create a public void. I think it's void. I should double check this. The downside of this is you're not going to get a interface or something to override this because they can follow any format. What it's looking for is a signature to match. So we're going to do an async task, actually, because these are async functions. and we're going to do a pixel update. And so the pixel update is just the name of the thing. So we need to know pixel update as a string and be able to send that to wherever we want our message to be received in order to actually send this data. And then the arguments here are just whatever the arguments are. It's just a function. So all we're doing is remotely invoking procedures on clients or servers. That's how this is all working. Instead of directly invoking functions, you can say, I want to invoke this and execute this and send that request off to the server. The server will see that and then figure out how to handle that and maybe even send it off to clients or do something else for you. So that's how all of this ends up working, is we're creating a function that is exposed to remote clients that are connected to this server. And so they can pass in those parameters and invoke it just like they would another function, except it's just on a remote server. And so that's what we're going to do. We're just going to add our pixel data model, include that, and data, sure. And there we go. So that is all that we need to do this. And then we can use the clients, await clients, which is a static, global static thing. I think it's static. Might just be part of the hub, sorry. So the clients is going to be a list of all the clients connected to this hub. And then we can say, select all of them. There are ways to filter this. So you can see it's suggesting all except. So you can filter down people who do not, or clients that would not match a specific criteria. There are other options. For example, you have direct access to the caller. But in this case, we want to just send this out to everybody. The way that I've been kind of thinking about this is, in order to avoid things getting out of sync, the best way that I've found is to have an authoritative server and then clients that just kind of represent that state. They don't actually manage or otherwise control their state. They just send state changes up to a server, and that server sends the desired state back. The advantage of that is you don't end up in a case where things desync and get out of get away from one another, because the server is always sending back a valid state. You don't have a case where a player says update this pixel to red, and another player comes in and says update this pixel to blue, and then they both get sent back to different clients in different orders, and people end up with different appearances because of async things. So this is an attempt to help with that. So what we're doing is finding all of the clients and then sending an async message to all of them. We're just going to say, send back a pixel update with our data. Pixel data. That's what I called it. There we go. I think we could even make this a little bit nicer by using name of here. And there we go. So name of is a special function that's going to grab the name of a reference. In this case, our pixel update function, and it's going to render that as a string. So this and the string that I replaced it with are the same thing. The advantage of doing this is that now it is a syntax error if this doesn't align. So if pixel update gets changed and this becomes pixel updates, we now have a syntax error. Whereas if that was just a string, that doesn't happen. And then you run into issues where things disappear, or you run into weird things where messages are coming up to the server, but they're not going out to clients, and you can't figure out why. And it's because the names don't necessarily match. This helps fix that. So this is just something that I've picked up and like to do. You definitely don't have to do this, but there are strings just inherent in this. And so trying to remove them has, in my mind, made that a little bit easier. And that should, I think, handle most of that. So our hub is done. The next thing we need to do is add 2 lines to our client. So what we're going to do here is add a map hub. So we're going to map our hub to an endpoint here. So this is using some of the SignalR stuff that we brought in. So if we do map hub with the hub that we just created, So the Pixel Party Hub, there we go. We want to map that to some endpoint. So we're going to map this to our, there we go, Pixel Party, there. And so now we have this endpoint that is mapped to this. This is similar to a REST endpoint, but this is a hub. Hubs can have multiple of those events, multiple of those remote procedure calls attached to it that you can invoke. Ours just has the one, but that doesn't, just because you're using a single hub endpoint doesn't mean that there's just one endpoint there. There might be multiple. So that's what's happening, where this is taking our hub and mapping it here. And so now we should be able to run this. This will cause an error, but that's fine. We can fix it. So we should see something break here, I think. I'm hoping. There we go. All right. So we get an invalid operation because we're trying to map a hub when we haven't added the SignalR service to our website yet. So in order to fix this, we need to go and add a service that's just up at the top of this. So while we're building all this other stuff, we need to just do builder.services, add SignalR. And that's going to go and add that. If you get lost, it's in the error message. So you should be able to just follow that and it should help you out. But that's needed to that needs to happen before we invoke adding hubs and things, because we haven't initialized all of the services that run SignalR yet to actually start interacting with it. And there we go. That should hopefully get us a working server. So at this point, hopefully, we can jump over to the client and start working with this. This doesn't actually tell us too much, but it's there. So the next thing I'm going to do is grab this. We can actually just leave that open for now. That's fine. Actually, I'm going to close that, thinking too far ahead. And let's change some runtime parameters. I like to do this just from my side of things, is to have everything start at a specific port, because otherwise Visual Studio is going to give you random ports that don't conflict with your environment, which is great. But if you're trying to connect things to it and they aren't what you expect, it can get a little bit hard. So we're actually adding two URLs here. We have an HTTPS endpoint and an HTTP endpoint. So I'm going to change these to 5000 and 5001. And there we go. And so this should make it go to those ports instead of using the previous ones. There's no actual difference here. You don't need to do this step. I just find that it makes it easier when I'm building things to always use the same ports. So that's just my preference. So we now have a running server. It should have a functioning SignalR hub running on it. So now we need to add a client. So we're going to do that next. I don't think I need to stop this, but we'll see. So if I go, yeah, okay, I do. Let's go and add our new project. And this is just going to be a console app. There we go, console app. And we're going to go pretty example dot thanks. That's the name. There we go. And so this should just create a one-line client for us. We need to do a few things to actually get this all working. But the first thing we want is we actually want to add our SignalR client packages. So these are the packages used by your client in order to communicate with SignalR. So you actually have those APIs available to you. So let's do that and go and add another NuGet package. There is a specific client package here. So let's go here and go SignalR.client. And this should find the one we want. So ASP.NET Core.SignalR.client is right here. And then we can go and install this. And this should get our console app everything that it needs in order to communicate with the server we just created. And so now everything should be able to at least get implemented. We haven't quite gotten that far yet, but that's sort of what we're building up to, is being able to actually send these messages back and forth. So now that that is done, let's actually start implementing this and start actually throwing things together. So just to make this a little bit easier on myself, I'm going to swap things. There we go. Sorry about that. But this way I feel like I can actually look at you instead of just staring off into wherever. That was poor planning on my part. So what we're doing here is we're going to actually start implementing all the different steps to actually get this communication working. So the way this works, first thing we're going to do is we're going to just change this to starting client. Just so we have something to say that this is going. It's kind of following that print line statements for debugging. By having different print lines at different points, you know if it reached a certain point, and it saves you from attaching a debugger because we probably aren't going to have one. At least the way I'm running this, I'm running them from a Windows terminal, so there is no debugger attached to them. So if anything goes wrong, I want just a quick way to find that. So the first thing we're going to do is create our connection to the hub that we just made. So we're going to create a hub connection using the hub connection builder. Connection builder. Go. And we want with URL, so we're going to give it some URL to go out and find this hub. So I'm going to send it out to localhost 5000. Here we go, /pixel party. So if you're wondering where that's coming from, that is coming directly from here. So I switched everything over to be on localhost 5000 as my port. And then the hub name is coming from this final part. So /pixel party is coming from there. So we go to our program again, and we can build it. And there we go. So we build our hub connection. This gives us a connection to our hub. There are other ways to do this. It's a builder pattern, so you can kind of experiment. And then we need to make sure we actually include our client. There we go. And so that gets us our hub connection. The next thing we want to do is start registering these callbacks. So now that we have the hub, what happens when things happen? So the next thing I'm going to do is actually register the callback function. So the way you do that is taking your hub connection, you can register these callbacks. So on a specific event, in this case, a pixel update, we want to do something. And so this is going to be a little bit angry at me. There's two ways to do this. The one that I had is an action, which means it's just invoking it, no arguments here. So if you just want an action that can be invoked on clients, this is how you would do that. Also, these names do not need to match to what is on your hub. This is a message sent to the clients. So these are client messages. When the client receives a pixel update, we want it to take the data. So we're going to actually use this with our pixel data model. No, we haven't included that yet, so let's go and do that. I just click and drag. There we go. And so let's import that. And now inside of here is the function that's going to get called whenever our server sends us a pixel update message. And so in order to get that to happen, we can just write something out. So let's do that. If you're still learning C# or maybe unfamiliar with this string, this is a string interpolation. So if you put a $sign in front of it, it's going to interpolate your strings for you. So you don't need to do replacement with like special characters or anything. You can just inline how you want your stuff to work. You can even inline functions. So we're just going to say pixel update received at, and then we can just do curly brackets and do at the X and Y coordinates. And then I also want to print out the red, green, and blue values here. There we go. And that's that. So when we receive a message now, what this is going to do is it's actually going to process that data. The serialization between client and server is already handled for us. So we're working with strongly typed data. And then we actually can grab that and do something with it. In our case, we're just printing it out. But you can do other things too. Again, it's just a remote procedure call. You're just invoking something on a client or server from some other client or server. So this gives you a way to do that. And then we can just finish that. And then the next thing we want to do, now that we've set up these callbacks, is take our connection and start it. Because we're using top level statements here, it should support async stuff. So we don't need to declare like a async main. This should already just work. And the generated code should handle that for us. So this will get us enough to actually connect and start listening to things. So let's do that. The next thing I think, now that we've done that, is to just write out our connection established. Sure. There we go. So we have connection established there. When that happens, we know that we've actually started our connection to our hub. SignalR can detect disconnects and reconnects for you, so it can handle some of that for you. If you want, you can also connect to those events. So we can have hub connection and actually grab some other stuff here. So there's reconnected and reconnecting. So if we want to have something when we reconnect, add a message to that specific event, maybe you lose internet connection and then reconnect back to your host. This gives you a way to do that. Because we're streaming this, demonstrating like internet disconnections is a little bit hard. So we're going to avoid that a little bit. But here we go. And so the next thing is I actually want to send a message and invoke something. So that's what we're going to do. We're just going to say, take our hub connection and invoke something. So I mentioned previously when we were talking about this, what this is RPCs, or remote procedure calls. So an RPC is, I guess, a remote procedure call. But what that means is that there is some remote device, some remote server that has a series of functions defined for you that can be invoked by another process. So in this case, we're actually sending this message across saying, run this function over here. And so instead of running it locally on your own machine, you can actually send this off to a server and do that. It gives you a nice way to do back and forth messaging and sort of do event-based stuff. And so the cool thing with this is because it's remote, it means we can put our servers wherever we want and start invoking those things. So we're going to do invoke async, which is going to asynchronously invoke a specifically named endpoint on our hub. So what we can do here is say pixel data model. And then we need to match that name again. So pixel update and send the data we want. Again, it's all encoded behind the scenes for you. So this is strongly typed data for you. You don't need to send like JSON strings back and forth. You can send the rich objects that you want. So we're actually using a record here. And it doesn't just need to be one thing either. You can write functions that accept multiple arguments, and the same is true here. You can write invocations that also pass multiple arguments. So if you want to pass in a user object as well, that's possible. So here we go. Let's create this with a pixel data model. One of the cool things of using records is the constructor is created for you. So we can just pass in some default values here. We'll do white with red, green, and blue all at 1 at 0, 0, and send that up. So if we do this, that will send our message. And then the final thing I want to do is just wait and wait for something to happen. So we're just going to console.read, kind of hold our console there so it doesn't immediately exit. And then at the very end, let's just close that. So hub connection, stop async. And so that will give us a way to actually stop this and return from this async message. And that's everything we need to actually get started here. To actually set everything up and get all the communication working, that's all the code we need. And It's 20 lines. So hopefully this works. So what we should see is we should be able to connect and actually see this pixel update received come back to us, because nowhere in our code are we saying trigger this thing or invoke this thing. Instead, we're actually sending a message up to our server, which is coming back to us. So let's go in and see if it works. And so we can do, if we look at where we are, let's make that a little bigger. And we'll do, go into our client and just run this. And hopefully we will start seeing our things come back. Nope. What have I done? The type of namespace name does not exist. Did I do something wrong? Maybe. I might need to build this. So let's give that a shot. The easiest way to do that is, I think, is just to click build there. And there we go. And hopefully that fixed it. I think it should have. There we go. Yeah, so we see starting client. So that means our code has started running. And then we get a whole bunch of errors. So what did I do wrong? No connection could be made because the target machine actively refused it. Localhost 5000, no connection could be made. Is our server running? No. Cool. All right. So because we didn't start our server before trying to make this connection, we're getting a whole mess of an error. An HTTP request exception, no connection could be made. We're not going to solve all of the safe programming stuff that we could do here, just because that would take a while. But this is one of the errors you can run into, is if you try to connect to something and it's not there, how do you handle this? So that's one of the errors. Let's go and actually solve that by just starting our server. So if we go here and run our server from Visual Studio, that should get us all started. And there we go. So the server is running. And so now we should be able to run this and hopefully actually connect to our port. There we go. So this is the entirety of what we've created so far. We've connected to a client. We have a connection established, and then we just send an empty update, basically. So all we're doing is just sending that update back up and then getting it. But what we can do now is split this and actually create another one. So that first original client is still connected to the server. It's just waiting for more messages. So what we can do is actually go there. Building, there we go. There we go. So if we run this again, we will get the connection again, and we'll send the other pixel update. But we'll also see another message came across in the original client because it's still waiting for these messages. And we can keep doing this. We can stop this and run it again and get a third message. And this gives us a way to kind of just demonstrate that thing. This is all running on my computer because that's just what I have. But the power of this is that it doesn't need to be all local. You're not just sending messages between processes locally. This is going up to a server, so you can actually have this connecting to multiple different people all over the place. One of the common examples is a chat app where you type chat messages back and forth using SignalR. I've tried to, there seems like there's lots of examples like that. So I have tried to not recreate that. We're doing something slightly different, but that's sort of what we've been creating. And yeah, I think that's most of what I wanted. There's a few other things I want to just quickly kind of add on, but other than that, I think that's mostly it. If this is something you really like, now seems like a good time to mention that this is a 3-part series. This is the first, where we're just kind of introducing all of this so you can see more about that. The next step is going to be actually introducing this into a Blazor app. So you can actually have a web app that is running and able to actually interact with these rather than just a CLI. And that way people can actually log on to your server and send messages back to you. And then the final thing is we're going to actually implement a feature where you're actually going to be able to draw on a canvas and send those drawings between different people. So that's sort of what we're doing. This is sort of the introduction. We just kind of wanted to cover some of the introductory steps and hopefully get you introduced to that. And yeah, hopefully this is interesting. Next thing I want to do is just make it so we can actually send more interesting data than just the default. And so that's what we're going to do next, is just make it so that the data we're sending is not just always this. And the advantage here is that this way we can actually turn this into a debugging tool. Because we're eventually going to have a web front end for this, you're going to be able to see things. But I think I'm going to want some way where you can go in and start sending messages and doing more admin-y tasks to whatever is there. And so we're going to kind of turn this CLI tool into a tool for that purpose. And right now it's not that. So that's what we're going to be quickly adding here in the next 15 minutes. If anybody has any questions about what we've been building so far, especially around how the messaging is working or what we're building, definitely let us know. More than happy to go on tangents and answer questions. Or again, you can reach out to me offline and I will try to follow up and connect you with people that make sense and can answer your questions. This has sort of been my project for figuring out how to learn SignalR, and so we're still kind of going that route. But yeah, so let's do this. The cool thing is we don't need to change our server, so the server can stay running because it's just a server, and all it's doing is rebroadcasting the messages. So unless we are going to change that logic or going to otherwise change the data model, we don't need to do too much. So the position of my webcam can cover content. Okay. Oh, okay, that makes sense because we have this. That's good to note. Yeah, wasn't thinking about that. But yes, that's a good call out. Thank you so much. Cool. So I'm glad you're interested, but let's go and add this. So what I'm going to do is actually change this so that we have some inputs that we can read. So let's do this. I don't really want to write a parser, so this will be interesting, but we're going to set up just a basic input string with some random data, I guess. Random equals new random. There we go. And then while our input is not equal to, here's the thing with strings. There's multiple ways to do strings. I've almost always found that it's better to use equals compared to direct equality. The reason for that is you can actually run into weird locale issues if you aren't comparing things. And so by doing it this way and doing dot equals, sometimes you can avoid those. So we're going to see if this is just equal to quit, just so we have a way to exit this. And then we can do a string comparison with a something to ignore case. So we add capital quit versus normal quit, or capitalize the first letter or whatever, it will still catch that. And we're just going to loop until input is that. And to do that, we're just going to set it equal to console.readline. And again, this is not defensive programming. This is more intended as a developer tool and something more of a demo. So there are definitely things that are done to be fast and not done to be correct. Just throwing that out there because we're going to kind of hack this together a little bit, just because it's fast. So what I'm going to do is actually split the input and assume that we get a 3-integer string separated by commas. So we're going to grab this and say color equals input split. We're going to split it by a comma. Here we go. We could do spaces, I suppose, but we're just going to do a comma. And then from here, we can take those and convert them into integers. So this doesn't seem like a good idea, but we're going to do it. So we're going to do red, color 0. Again, we're doing this for speed, not doing this for correctness. So input.parse, go. And we're going to copy this 3 times. So again, lots of assumptions are being made here because I just kind of want to do this quick to get it working. So don't copy this. But that's the thing. I will fix this up in the code that I put out on GitHub, which should be coming out shortly after this, once we do all of that. But this gives us a way to actually pull out these color values that we input and then upload those to some random position. I don't know why I'm using random positions. It just seems smart. So there we go. Let's go and send that now. So we can do this same invocation here. We're going to just await this hub invocation with the same arguments and sending our same pixel model. But instead, we're going to do red, green, and blue. And I remember those were supposed to be floats. We're going to change that, I guess. Oops. But anyway, this should hopefully give us a way to actually send custom data to and from these clients. And we don't need to update our server. So I haven't stopped the server code at all. The same server is still running. All I've done is updated the clients. That's interesting. Don't know why that's down there, but that's okay. And so now we get 2 clients connected. That one's a little bit awkward. But what we should be able to do is now enter the same thing. So 1, 1, 1. There we go. And we will send our update. But now we can also send custom information. So 10, 0, and 255. And now this custom information is being sent from one client to the other and gives us a little bit more usefulness as far as actually sending information. And basically what we've built at this point is a chat app because that's all it's doing. Instead of sending strings, though, with a username and a text message, we're sending pixel updates. That's the only difference. The only difference is the actual data model we're using. Otherwise, this is just a chat app. At this point, we just have a terminal that can chat with itself. So if you do want to get started with this, there is a link that was just dropped in chat, which is great. That is aka.ms/getstarted SignalR. That will walk you through how to get started and actually jump a little bit ahead into integrating this directly into a web app. So if that's something you want to do, we're going to be taking a little bit more of a look in that. Can you use that to update pixels for a whole monitor? So I'm thinking probably not going to do a whole monitor. My hope with this is something, if you come into one of our events in a Microsoft Reactor, there's a few of them across the world. If you come to one of those, my hope is that this will be something that you can actually interact with, and we'll have a few of them in different locations. So you can draw a picture and then people in one of the other Reactor locations will be able to see that. That's the end goal here. We're still iterating on that. We're building it live. So there's still things to happen. But it's not so much intended to update your screen as to do more of like an art display thing. So think like pixel or like LEDs, for example, in like an LED matrix, something like that. You could use it probably for your computer screen, for example. But there's a lot of those. So I don't know if I'd recommend sending them like 1 pixel at a time for a computer monitor, just because it turns out there's a few million pixels and that's a lot of messages. Yeah, I don't know. That's a good question though. If you do want to see a way where we could send like actual pixel data to do that, that might be something that could be interesting. It gets a little weird with like having networked people drawing things. There are some thoughts there that we would have to work out, but that could be a really fun project, I think. So yeah, I'll think on that. That's cool. Good idea. But yeah, going off on tangents, but I think this is fun, and hopefully you'll enjoy what we end up building here, because I'm really excited for it. So yeah, there's 2 more weeks of this, both happening at the same time, Thursdays at 4 p.m. Pacific. And so if you want to come and join in, or you want to follow along, there will be a GitHub link with this entire project. You can actually grab and hopefully run and do your own thing with, or maybe even contribute things. I haven't even, that could be cool too. So if that's something you want to get involved in, then let us know. But I think that's it for now. There was a survey link dropped into the chat. We really appreciate it if you fill those out. Those help us kind of understand if this is something you like, if our style is maybe not great and we should change something, or there's topics that we're just overlooking. Yeah. Thanks everybody for participating in chat too. That makes this super fun for me. And so it's one of the best parts. And yeah, thanks everybody.
Thank you, Sam, and thank you everyone for joining. And don't forget to join next Thursday. We hope to chat with you all then. Have a good one. Until next time.
Thanks everyone.